Algebra 2. So we're going to continue our work with our trigonometric functions. We're going to practice with finding the exact values of x and y on our triangles that are labeled here. We're going to use the special angles table to determine the trig values of your angles. So that's on page 557. It's also in your paperwork here, what the degrees are for each of these special angles that we're going to be working with. So no calculator here. We're going for exact answers, which means that when they're radicals, we're not going to approximate them with our calculator. We will leave them in simplest radical form. All right, so let's take a look at our first triangle here. It's a 30, 60, 90 degree triangle. And our job is to find out the value of this x and the value of this y. So we're going to start by thinking about what our x is. And I'm noticing that the x is on a leg and the 7 here is on a leg. We're dealing with legs. So I'm going to look at this angle. I can look at either one, but I think I'll go ahead and pick off this 30-degree angle and notice that my opposite leg over my adjacent leg would be the tangent function. And so the tangent of 30 degrees here would be x, the opposite leg, over 7, the adjacent leg. So that's why I've written tangent of 30 degrees is equal to x over 7, opposite over adjacent leg. All right, well, I look at my table and I see that the tangent of 30 degrees on my special angles table is root 3 over 3. I can approximate that on a calculator, but for what we're doing here, we're going to use our exact value, so we're going to use that table. So square root of 3 over 3 then is equal to our x over 7. Now I'm going to solve for x. I'm going to use cross products. So 3 times x is equal to 7 times the square root of 3. That's my cross products written out. And then I'm going to divide both sides by 3, and I'll find the exact value of x is 7 rad 3 over 3. And notice those 3's do not cancel because the 3 inside of the radical cannot cancel the 3 outside of the radical. So here we are, simplest radical form. So remember, for simplest radical form, all perfect squares do have to be removed from the radical, and no radicals can be left in the denominator. All right, the second part of sample 1, we're finding y, which is the hypotenuse of this triangle. Again, we have a choice. Which angle do we want to use, 30 or 60? Well, let's see. Which one am I going to choose to use? Well, I notice that I have this leg labeled 7 and the hypotenuse labeled y. So I can choose either sine or cosine. I think I'll go with sine of 60 degrees here. The sine of 60 degrees will be my opposite leg. So opposite of 60 degrees, that leg is 7 over my hypotenuse y. Sine of 60 degrees is 7 over y. Again, I have choices. I pick the angle that I want to work with, and I then write my ratio based on the angle I have picked. If I had picked 30 degrees here, then I could have said that the cosine of 30 degrees is 7 over y, and it would give me exactly the same answer. So remember that when we are setting up our ratios, it's always going to be set up in relation to the angle that we are working with. All right, so here we have, again, sine of 60 degrees, the opposite leg over the hypotenuse, 7 over y. And on my table of special angle values, I'll find this sine of 60 degrees is root 3 over 2, so that's equal to 7 over y. I'm going to use cross products to solve for y. So square root of 3 times y is equal to 2 times 7. And then I'm going to divide both sides by square root of 3, which will give me y is equal to 14 over root 3. And that looks like a pretty good answer, except for it's not simplest radical form yet. So remember, we cannot leave any radicals in the denominator when we're writing in simplest radical form. So to rewrite this, this fraction so that the radical no longer is in the denominator, we're going to multiply by the number 1 in the form of root 3 over root 3. And remember, when you multiply a radical against itself, all that's left is the stuff inside. So down in the denominator here, all I have left is 3, and in my numerator, I have 14 root 3. And again, these 3's do not cancel because this 3 is in the radical and this is outside of the radical. So my final answer in simplest radical form is y equals 14 root 3 over 3. Again, I could have used my calculator to approximate what is 14 times the square root of 3 approximately divided by 3, but we're not asked to do that in this particular problem. We're asked for the exact values, which means we need to leave it in radical form. Next sample, sample 2. Well, we have another special triangle here, a 45, 45, 90-degree triangle, and again, we're trying to find the value of x and y exactly. So again, we're going to continue to use that table of special values for our special angles. And what we're going to do first is we're going to take a look at x, and we're going to say, how do we solve for x? Well, let's see, I have x and I have 4 root 2. Those are both legs of this right triangle. So I can pick either angle measurement. They're both 45, so in this case it really doesn't matter which one I pick. So let's see, I think I'll go ahead and say, look, let's look at this 45-degree angle and notice that the tangent of this 45-degree angle will be the opposite leg, which is x, over the adjacent leg, 4 root 2. So tangent of 45 degrees is x over 4 root 2. I look on my table and I find out the tangent of 45 degrees is 1. And so solving for x using cross products, there is a 1 over 1 here. So x times 1 is x, and 1 times 4 root 2 is 4 root 2. So there I am. X is 4 root 2. And that makes sense. In a 45, 45, 90-degree triangle, the legs will have exactly the same measurement. So they're both 4 root 2. What about the hypotenuse? Well, to find the hypotenuse, I can go ahead and I can say, well, look, I know this is 4 root 2. That's safe. This one, if I made a mistake, I don't want to use, so I'm going to go ahead and choose this one. And then the hypotenuse is y. So let's see, for this 45-degree angle here, that would be the adjacent leg, 4 root 2 over the hypotenuse. So the cosine of 45 degrees is my adjacent leg. It's labeled 4 root 2 over my hypotenuse y. I'm going to look on my special angles table and find out that this cosine of 45 degrees is root 2 over 2, and that's equal to 4 root 2 over y. And then I'm going to use cross products. So I'm going to multiply root 2 times y right here, and that's equal to 2 times 4 root 2. I'm writing that here. And then I'm going to go ahead and set about simplifying that. Square root of 2 times y I'll copy. 2 times 4 is 8 times radical 2. Dividing both sides by rad 2, those radical 2's cancel out, leaving me with y. These radical 2's cancel out, leaving me with 8, so y is 8. That's the length of my hypotenuse exactly. Okay, what about sample 3? Sample 3 asks us to solve a right triangle. So if we're solving this right triangle, we're given 2 pieces of information. We're told that angle B is 53 degrees. I've already marked that in. We're told that A is 12. So that's the side opposite angle A. Remember, these right triangles, when we are solving a triangle, are always labeled a very specific way. The little a is always opposite of angle A. Little c is always opposite of angle C, and little b is always opposite angle B. All right, so with that setup in mind, we're going to first figure out what our angle A is, and that's going to be super easy, because remember that the 2 acute angles in a right triangle must be 90 degrees. They must be complementary in order for 90 plus 90 to be 180, the sum of all the angles in a triangle. So all we have to do to figure out this angle A that's missing here is note that something plus 53 is 90. That means if we take 90 minus 53, we're going to get our angle A, 37 degrees. Done. All right, now we're going to use some trig functions to find the length of B and the length of C. So we're going to start with B, just because I'm going in alphabetical order. To find B, I know that I have the length of A, so I've got a leg I don't know and the other leg I do know. Legs. Legs, which trig function can I use if I'm trying to find out something about one leg and I know the other leg? Well, adjacent leg, opposite leg, tangent. So I'm going to do my opposite leg, which is B, opposite of 53 degrees, the far away leg, B, over my very close leg, my adjacent leg, 12. B over 12, opposite over adjacent, is the tangent of 53 degrees. Then I'm going to solve for B, multiply both sides by 12, and I have B is 12 times the tangent of 53 degrees, and then I use my calculator. So this time, because these are not special angles, we are going to get approximations on our calculators. When I plug 12 times tangent of 53 degrees into my calculator, making sure that my calculator is in degrees mode to give me a correct answer, I will get 15.9245, rounding that off to the nearest hundredth. That's just our protocol. Rounding off to the nearest hundredth is what's expected unless we're told otherwise. We have B is equal to 15.92. The only other thing that we have to figure out then is what is C? Okay, we're going to go again with what we already know for sure. I might have made a mistake on B, so I won't use that information because I don't have to. I do know for sure A is 12 and that this angle is 53 degrees, and I'm trying to find C. I know the adjacent side of this angle, and I am trying to figure out the hypotenuse. Adjacent hypotenuse. That's the cosine function. So I'm going to say the cosine of 53 degrees is the adjacent side, 12, over the hypotenuse, c. So cosine of 53 degrees is 12 over c. Now I'm going to use cross products so that I can solve for c. Cross products will say c times 53 degrees is equal to the 1 that's hiding under here, times 12. 1 times 12 is 12. And then I'm going to divide both sides by the cosine of 53 degrees, so I have c by itself. So c is 12 over cosine of 53 degrees. Sometimes your trig function ends up in the denominator, sometimes it doesn't. It depends on what your ratio is, and you have to write the ratio in the correct order. Using my calculator at this point, 12 divided by cosine of 53 degrees gives me 19.939 and some other digits past that. Rounding off to the nearest hundredth, c will be equal to 19.94. And that concludes our samples for today's work. So it's time for you to make sure these are in your notes, and we'll see you next time.